Hello mathematicians, we're now going to have a look at coordinate methods applied to geometry. And this is how we usually find these questions presented on assessment tasks. So let's have a look at this question here from the text. So we've got points 0, 0, P, 8, 0, so this is obviously not quite the right diagram. So P, which is 8, 0, and Q, which is 0, 10. They form a right angle triangle, and let M be the midpoint of PQ. So first of all, find the coordinates of M. So the coordinates of M are going to be the average of the x's, so that will be 4, and the average of the y's, so that will be 5. Find the distances OM, so that's this one here, PM, and QM, so PM and QM. So this will be our distance formula, because while this might look like a right angle, we can't be sure that it is. So distance formula for OM, so OM will be the square root of the difference in the x values of these points, which is 4 minus 0, which is 4 squared, and the difference in the y values, which is 5 minus 0, which is 5 squared. So that's square root of 41, which we can't break down any further. PM, so from 8, 0 up to 4, 5, so PM is going to be the square root of 8 minus 4, which is 4 squared, and 0 minus 5, which is 5 squared, so again root 41. I think we can see a pattern here. QM is the square root of, from 0 to 4 is 4 squared. You notice I'm not being too worried about which ones I take first and second here, because we're only interested in distance, so the sign is unimportant. It's just a difference in x values of 4 and a difference in y values of 5. So again, that will also be root 41. So what we get then, so all these are okay, and for part 3, explain why a circle with centre M can be drawn through the 3 vertices OP and Q. Well, the reason of course is that if these distances are all the same, and this is on a straight line, this is the radius of our diameter of our circle, this is the radius, so the circle has to pass through all those points just there. Now the next question is from the 2012 HSC Advanced Maths paper. And I've included a maths paper question here because every year, for as long as I can remember almost, there has been one of these questions worth somewhere between 6 to 10 marks, and they are easy marks. All we've got to do is be really careful and get our head around what the question is telling us and what we have to do to answer the question. And that usually means spending a bit of time thinking about the diagram. So this diagram shows a triangle ABC, so we jump down, we can see ABC just here. The line 2x plus y equals 8, so we see what that line is, meets the x and y axes at A and B respectively, and the point C has coordinates 7, 4. Now, without reading the questions, fill in stuff that we know. So at point A, the coordinates of that, we know the x-coordinate is 0. What we're doing is finding where this straight line cuts the x-axis, which is where y equals 0, which will be 2x equals 8, so x equals 4. So this is the point 4, 0. This point up here, point B, is where x equals 0. We cut the y-axis, so that is the point 8. So while we may not need it, but in here we've also got a right angle triangle where this distance is 4 and this distance is 8. So we just have to have our eyes open about the setup here. And then we answer them one question at a time, knowing that they've probably got some master plan or link or flow through the parts. So part 1, calculate the distance AB. Well, we could use the distance formula, square root of difference in the x's, difference in the y's, etc. But we also know that the distance formula is just based on Pythagoras, so the distance AB is just the square root of, and this is all our formula gives us, the square root of 4 squared plus 8 squared, which is the square root of 16 plus 64, which is the square root of 80. We know that we'd be able to break that down, so if we think of numbers that go into this, we might not get the biggest one straight away, but I think the biggest one is a 16 by 5, which means that this would come down to 4 root 5. That's a good 2 marks in a HSC question. Now the next part says it is known that AC equals 5, so that distance is 5, BC equals root 65. Do not prove this. We know that we could prove it. The reason is that in this question they've drifted off straight coordinate geometry, and as they so often do in the HSC questions, they've tried to mesh 2 areas together. So we can no longer keep our knowledge isolated in little packets. They're saying calculate the size of angle ABC, so this angle up here. Now if we do compartmentalise our knowledge too much, we could say, well, no, I have no idea what they want me to do here. And I could wander off and do something about angle of inclination of the line and so on. But you might recall from junior school, or you should recall, that if we have a triangle which has 3 sides given, and we now know the 3 sides because we've got all 3 supplied to us, then what we could do is use the cosine rule. We're not going to do it now because that's the next topic, I think, trigonometry, but we could just use the cosine rule to find that angle there. Not too bad either. Part 3, the point N lies on AB, so here's AB, such that CN is perpendicular to AB. So, you may need to read that a couple of times, and I may need to change the pen colour because this is getting congested. But if N is somewhere on AB such that CN is perpendicular to AB, this is what we're after. And we have to find the coordinates of N. So if we're going to do that, then we've got the means of finding the slope of this line, and we know that this line is perpendicular to it, so we've got the means of finding that slope. If we can find the slope and one point that that line passes through, this is the line CN, we can get its formula. How do we find where 2 lines intersect? We solve simultaneously. So that gives us a plan, and we can see that that plan is probably worth 3 marks in terms of calculations. So I'm going to squeeze it in up here because I want the diagram with me. So my first task is to get the slope of AB. Now it's written in standard form, so I can just do that by observation. The slope of AB is minus A over B, so that's minus 2. Does that make sense? Yes, this line is trending that way. Therefore, the slope of CN is minus 1 over minus 2, which is a half, because they're perpendicular. Thank you, computer, for jumping there. So, now that we have that, the slope of CN, therefore the equation of CN is y minus y1. So that's going to be y minus 4 equals m outside of x minus x1. So that's 7. Multiply through by 2. 2y minus 2 equals x minus 7. So therefore x minus 2y minus 5 equals 0 is our equation for Cn. And then we simply solve Cn and AB simultaneously. Now, I'm not going to do that here for two reasons. One is I've run out of space, and the second is I know that you know how to solve equations simultaneously, so you could do that part just there. Now we get to the end of this, and shock horror, there are no questions to do. The reason for that is that what I want you to do is to go through and do all the HSC questions on coordinate geometry, because they are essentially of the type that you need to do here. So we've got on this OneNote site past HSC questions. Have a go at those now.